So, what in today's lecture, I'm also going to talk about something like some non-routine kind of questions. So, it is very important that you speak your mind out. Otherwise, it could be quite depressing if you have not done it for the few students. And if somebody has already done the thermodynamics, so they are already aware of the thermodynamics, they will rather enjoy it and they'll pick the question and put it to the good use. Because as you know, JE ask 80% of the questions, usual questions, which you have done in your practice problems. But sometimes they will give you some kind of, some kind of minor twists. So we are just tackling those twists. So 1 mole of amino acid NH2CH2COH, it's a hypothetical question because I don't know the glycine. What is the correct pK1, pK2? But I've chosen it where pK1 is close to 2 and pKa2 is close to 10. So is added in 10,000 liters of water. How many mole of strong acid or base is needed to be added to reach isoelectric point? That is one challenging question you have. If some approach is coming, you're trying, that's very good. Come up, tell me what is the idea, how to proceed with this problem. Okay. Tell me
Yes,
how to solve this problem. What is the approach? I'm not interested in the answer. What is isoelectric point? Please define. You're the topper. That's your responsibility to carry all of them forward. Yes,
the cationic part of amino acid and anionic part of amino acid are in equal amounts.
exactly. Fantastic. So, do you agree that this amino acid, first of all, everyone know this? Please respond very quickly that as soon as you put it in the water, it will take the form of NH3 plus and CH2 and CO negative. This is called Zwitter ion. Everyone know this? Yeah. Ved, tell me, why is it
Yes.
taking Zwitter form quickly? Why it is there in the Zwitter form? You understand my question? Am I
Yes.
audible? Yeah. Why it is in Zwitter form? Why not in this form? Answer. Because
Because
this
of equilibrium.
because of COH is more than interested in giving the H plus ion and NH2 is more than interested in taking one H plus ion. And in this manner, they are more settled because, of course, the equilibrium constant of this acid-base reaction is very large. Okay. So whenever the equilibrium constant of acid-base reaction, meaning of this is COH is losing one H plus ion and NH2 is taking one H plus ion. So it's basically an acid-base reaction. And the K of this, K equilibrium of this will decide whether this reaction will take place. So this very readily form the Zwitter ion, but none like which, can you tell me one of the substance which do not want to go into the Zwitter ionic form? Just general knowledge. Do you know this? That this do not want to go into the Zwitter ionic form?
No, sir.
Isn't it? Do you know this?
No, sir.
No? Yeah, you must know this. And if you sulfonilic acid, that means if it's SO3H and NH2, it will quickly go into the Zwitter ionic form, but this will not. Entranilic acid will not. That's a very famous question because here NH2 is not very sufficiently, basic. Why? Because of what? The resonance.
Resonance.
Resonance will make it such a poor base that now it will know it will not, it's not interested. So here you can say the acid base reactions equilibrium constant is very small. That is why. Okay. So this one basic question when I got, then I would say that this question most of you are not understanding. So I will give the point is I'm not going to demoralize you. The last point. Okay. If you have done all the routine problems, then I can take this problem. Okay. So I just tell you very simple thing, very simple thing that whenever amino acid you take, you compare this amino acid with an acid what? Na plus Ha. Why? Amino acid should always be compared with what? Na plus Ha. Because this Ha negative can give one H plus ion and can take one H plus ion minus H plus ion. So this can become A2 negative and this can become what? H2A. So this Ha negative you very well know that can change into this and this. Very similar to the amino acid, because you know the amino acid NH2, NH3 plus, and CH2 and CO negative. They can react with water and they can behave in a two manners. Okay, it can form NH2, CH2, CO negative, and it can also form what? Tell me. It can also form what? NH3 plus CH2 and COOH. So this is anionic form and this is cationic form. All right. So this amino acid, just like this, HA negative changing into A2 negative, and it can change into H2A. Okay, this is the idea. So just like HA negative breaks into this and this amino acid breaks into this, anionic and cationic form. Another idea is this whatever concentration of this is there, that will change into these two. This is the idea. Idea number one. Everyone clear? So that is why we very well know that H plus of HA negative, Na plus HA negative, like sodium bicarbonate, is given by under root of K1, K2. That is why you simply write that if amino acid is there, like NH3 plus CH2, COO negative, then the H plus due to this will be given by under root of K1 into K2. That is why you use the formula. Okay. But a very interesting thing is, if you realize one thing, that a very interesting thing is that what is isoelectric point? Isoelectric point is the point where the anionic form must be equal to the cationic form. Suppose a positive, yeah, suppose let me write it, anionic form is equals to cationic form. Exactly equal, okay? So what is cationic and anionic form in the amino acid? So in the amino acid, you very well know. And what about this? That means H2A must be equal to A2 negative. If I talk about NaHA, then this should be there. And if I talk about the amino acid, then amino acid is NH3 plus CH2 COO negative. In that case, anionic form will be what? You very well know anionic form, and cationic form will be what? Cationic form will be NH3 plus CH2 COOH, and anionic form will be what? NH2 CH2 CO negative. So exactly they should be same. The idea is that we very well know that K1 into K2 is equals to concentration of H plus whole square into A2 negative divided by H2A. So if A2 negative is exactly equal to H2A, then K1 into K2 is equals to simply H plus whole square, and which gives us that H plus at this point should be equal to under root of K1, K2. So this is the pH at isoelectric point. This is the pH at isoelectric point. So what is so special? Okay, there is nothing so special. So what is the idea? But idea is now the interesting part is when you take Na plus HA negative, you will agree that HA negative reacts with water. It forms H2A plus OH negative. There is some equilibrium constant of this, and this equilibrium constant is called what? Kw upon K1. And the another equilibrium constant is HA negative plus H2O breaks into A2 negative plus H plus, and the equilibrium constant is K2. C will become minus X, that will become X and X. Simultaneous equilibrium, C will become minus Y, minus X, Y, Y. And we very well know that here, in this particular case, this is Kw upon, suppose 10 to the power minus 10. Minus 2. And this K2 is equals to 10 to the power minus 10. So we very well know this value is 10 to the power minus 12. And this value is 10 to the power minus 10. Which equilibrium constant is bigger? The lower one. So which is going to be larger? Y is going to be larger than X. If Y is going to be larger than X, this means what? This means that H plus ion concentration is going to be, that means you can clearly see that A2 negative will be slightly greater than H2A. And this is the approach through which you add this. Okay. So when A2 negative is greater than H2A, that clearly means what? Of course, A2 negative is not equal to H2A. So that means where we are. If this is the isoelectric point, this is pH is equals to 0. This is pH is equals to 14. So where we are? Towards left hand side or towards right hand side? किधर है हम लोग?
Left.
We are towards left hand side. I think that we are towards right hand side, because if A2 negative is more, that means it is more ionized. A2 negative is more, that means it is more ionized. Okay. So what is happening? If A2 negative is more, what do you say? When you titrate, if A2 negative is more, that means what? We are towards where? We are towards heading towards what? Basic side. And if H2A is more, then we are heading towards what? Do you understand what I'm saying?
So if A2 is more, then which H plus is more?
All right, agreed. Do you agree that when we start titrating H2A with OH negative, first it will become what? HA negative. Then it will change into what? A2 negative. If A2 negative concentration is increasing, that means we are heading towards which side?
Base.
Now you're convinced?
Okay.
So we are at isoelectric point, we know, at isoelectric point, we know that this is equals to this. This is equal to this. All right. Isoelectric point is this. But if I say that A2 negative is slightly more, that means what? We must have added some NaOH into it extra. Do you understand?
Yes,
so that means we are towards this side of the isoelectric point. So what we should do now to get back, add some acid. So that means if amino acid is added in water, first concept is clear. Amino acid added in water, that's called neutral point. So in this case, neutral point pH is greater than pH at isoelectric point. So I have given you a problem. Think about it. How much HCl? First of all, it is decided on this problem that how much HCl or a strong acid should be added. Okay, I have given how many moles of strong acid or base is needed. So what we need to add? Strong acid. Needed to reach the isoelectric point. That is the question. So I would say that till right now, I was explaining the question to all of you. You understand this question?
yes, sir.
Is it interesting? It looks interesting. It is going to churn up whole of your concepts.
Yes, sir.
So should I solve it or you try to solve it? You take some 15-20 minutes time and then you come back.
We'll try.
Yeah, it is better idea, because otherwise if I go to tell you the solution now, you will be depressed. Sir, this is the only way. No, there could be lot of ways of getting the answer. Problem is very simple, but if I straight away tell the solution, the beauty of this problem is gone. So this problem is there to churn up your mind, okay? Completely topsy-turvy, so that you start thinking. So that is my idea. So in this very late time, the ITJ, when you are heading for the ITJ examination, my style is, I believe that you have done all the practice problems, a lot of questions you have solved, and you don't think about it even whenever isoelectric somebody asked. You have a knee-jerk reaction, K1 plus K2 by 2. You get quickly, you very quickly get the answer. But this one question is going to make you think what really is isoelectric point by definition. Okay. So I leave with this one. In the next class, I will discuss. Till that time, you try it. I'll tell you, and hint I am giving you, it's only one line solution if you properly approach the problem. Okay. So I think that it is very unfair if I give you immediately solve the problem. So you take your time in front of camera. It is very difficult. So I have already shared 1 hour back this question files with you. So this file will remain with you. In my next class, I'll discuss all this problem. Today, I'm going to describe the problems. And if you want to clear some theory part, ask me, I will clear it so that you can solve the problem. You want to understand the theory part, I'll give you.
Okay.
Okay, if you have a little bit of understanding, little bit of less understanding, you can ask me, sir, what is isoelectric point? Tell me how to get the pH of this, what exactly, and I'll show you. So already students confuse between which point and which point. Neutral point and isoelectric point is confused. If I ask you what is neutral point, you have added amino acid into the water now. So it's not going to attain the isoelectric point. That is the neutral point. You will have to do something so that it will become to the isoelectric point. Do you understand this point? You add amino acid into the water. Will you say that it is at isoelectric point? You are only lucky that approximately gets to the isoelectric point, but exactly not the isoelectric point. I already shown you this. Okay. Okay. Let's try first question. Be responsive. At 25 degrees centigrade, a sealed rigid container is completely filled with liquid water. Can you see that picture? Yes. Sealed rigid container is completely filled with liquid water. If the temperature is raised by 10 degrees centigrade, what pressure will develop in the container? Mind it, it is not a gas. If it is a gas, it's a very simple thing. You can easily get it. But for water, alpha is given and K is given. The given equation of state for water is this. Some constant alpha is there, and you can see that alpha is the unit of alpha is what? Kelvin inverse. So this is somehow related with the temperature. And somehow this K is also, you can see what it is. K is equals to 10 to the power minus 5 ATM inverse. So you see that alpha is multiplied by T. So it is a dimensionless quantity, alpha T. And K is multiplied by P minus 1, where P is the pressure in ATM. And of course, 1 is the 1 ATM. So that is the equation of state of a liquid. A slight twist has been given. Not a big deal, can be given. And V naught 0 is equals to volume of water at 0 degrees centigrade. So can you find out the pressure developed in the container? Just talk about the idea. You can take your time, solve the problem, think about it. That is why I have given this file. I was preparing this file. I've given you. I'll just give you some hints. You know what is this alpha? Alpha you already know. Some way or other. Alpha is equals to 1 upon V del V by del T at constant P. Coefficient of expansion by cubical expansion. Physics में पढ़ते हो. The only thing is in chemistry, that means rate of change of volume with temperature at constant divided by volume. Can you say that this is rate of change of volume per unit volume? That is alpha for your help. And what is this K? This is minus 1 by V del V by del P at constant T. We call it isothermal compressibility. Why isothermal? See this, temperature is constant. So isothermal, rate of change of volume with pressure. What is this? Compression. So this is isothermal compressibility. And what is this? This is isobaric expansivity. This is isobaric expansivity. यानी कांस्टेंट प्रेशर पर कोई चीज का क्या कोफिशिएंट है, उसका वॉल्यूम कैसा बढ़ता है. Does it make sense? Does it make sense? Now,
Yes, sir.
yes, yeah. So that is why I was planning to share this file, but every question has to be picked up. So I picked up, I explain you the question so that you can solve it, all conceptual questions. Okay. Got it? What do you think? You will enjoy it problem? That's what you're seeking, some non-routine questions. That is a very simple question I have given. The coefficient of linear expansion is defined by A is equals to 1 by L dl by dt, just like the same. Like here, linear expansion A 1 by L dl by dt. So it is very similar to what? Alpha. It is 1 by V dv by dt. It is like in physics you study what? You study in physics or something like this? Physical chemistry is very close to physics. What
Yes,
is
sir.
that? ये क्या होता है?
Temperature.
Coefficient of linear expansion. Coefficient of, linear expansion, isn't it? And is it related to coefficient of, cubical expansion, volume expansion? Of course. So this question is related to that. I hope that you can figure it out. That is the hint. Can you do it now?
Yes, sir.
Okay, very good. See the next question. All these questions are conceptual questions. They're all going to be asked in ITJ the next 5 to 10 years. So we always try to be ahead of the IT, what they are going to ask, not like what they have asked. The correction term to the pressure and van der Waals equation, A by V square has the dimension of energy per net volume, joules per meter cube, where A by V is the energy per mole. Suppose that the energy of mole of a van der Waals fluid has the form U is equals to Ft minus A by V. At a given temperature, find the difference between energy of water as a gas and the energy of liquid water given the molar volume. What is V bar? It is called molar volume. Next question. Find the boiling point of water 2 kilometers above sea level. When you are at some mountain, what is the boiling point of water? Given P naught is equals to 1 atm. That means P naught means what? Pressure at the ground. TA is equals to temperature of atmosphere, 300 Kelvin. Delta H vaporization is 44 kilojoules per mole. M average air is equals to 29.8 grams per mole. And TB H2O, that we already know that boiling point of water at ground level is equals to 373 Kelvin. Using these data, can you find the boiling point 2 kilometers above the sea level? Let us try this question. Develop an equation for work produced in an isothermal reversible expansion from, we went to this, and in this, there is slight correction you can take here, V bar also, and here V bar is equals to molar volume. So the idea is you have to write P dV and integrate. So you will get. But the only thing is, only challenge in this is number of moles. So tell me what to do. Should I write here nRT by V into dV? The first term is very neat and clean. And what about the second term? Plus The second term should be what? BRT or NBRT? Tell me.
N square BRT.
BRT.
BRT minus A into N.
Yeah. NBRT. Do you agree?
Sir, we get V square in denominator, sir.
V square in denominator? Okay. Because V is, you want to say that V RT divided by V. You are dimensionally checking it, na? Good idea. So V is equals to 0.04 decimeter cube per mole. So this is per mole, and V is also, so V and B is cancelled, and so RT. So okay, for this is for 1 mole, it's all right. P is equals to RT by V. So P is equals to RT by V. All right. And B RT by V. P RT by V. It should have a dimension of pressure. And if I say that V is equals to decimeter per mole, then that is cancelled. So
Sir, from the original equation, when we transpose V, we'll get 1 by V square, sir.
original equation 1 by V square. No, this is one equation of state, some other equation of state, which is not related to, find the gas with equation of state. If you have written it gas with some equation of state, then we should take it that B should have a unit of what? B should have unit of V into RT by V. So here it seems that V should be a unitless number.
We also had one more V in equation.
Oh, yes. Yes. Oh, I got it. I got your point. Sorry. I just totally forgot. Sorry. Thank you. Thank you for helping me out. P is equals to RT by V and plus VRT minus A by V square. Very good. So we can see that this now VRT by V square. So one B is cancel RT by V, it is pressure. So B is of course NBRT by V square. It should be NBRT by V square. Now coming on to this one, minus A by V square, and this A has a unit of uh, liter square, I mean volume square, and pressure and mole inverse. So here it should be n square. Do you agree? So
Sir, N square BRT by V square, sir.
here also n square.
Yes,
Yes,
sir.
sir.
Because V is molar volume, so we can directly write it as V by N.
V is molar volume, all right, but B is also molar volume. B is also unit. What is the unit of B? B is of course liter per mole. Okay, so it is also have a dimension of molar volume, now. So this is molar volume and this is also molar volume. One molar volume is cancelled with one molar volume. How we are saying that n square it should be there?
Sir, in R also mole term will be there, no, sir.
Okay.
Yes, sir.
So you are saying that VRT by V square. So this is basically V by V I should put, and RT by V. RT by V has a dimension of pressure, and of course it is all right. And if we take this is pressure, of course, and this is volume by if I have 2 moles. Okay. You're right. It is n square. You're right. N square b. But check, please check n square b RT by V square. Does it make sense? Is it having dimension of pressure?
Yes, sir.
Yes, sir.
All right. So sometimes this dimensional analysis is also a headache. So that is the whole idea of this problem. That is equal to base. So what do you have to do now? P dV. So nRT by V into dV integral plus n square VRT by V square minus A by V square into dV. And I think that we can integrate it to get this. And if we put a negative sign, then it will be good for the chemistry. Put also here a negative sign. So the W is equals to, if you take it V1 to V2, will be nRT. V2 by V1 become V1 by V2 and minus n square. And if we take VRT minus A common and 1 by V square, that means 1 by V with a negative sign, negative will become positive. So 1 by V2 minus 1 by V1. Am I right? That will be the expression for one. Is that all right? And then you have to put the values and calculate. So what is the idea of this question? That's good. I think good question for a twist in ITG. Can they ask this? Can they ask it? What do you think? Provided the data is very good so that the calculation is less, they can ask. They can give a very good value of B, they can give very good value of A, and so they can ask. Do you agree? So if they can ask, what do you think? In question number 7, we can make a twist also. Can we also find delta U in the process? Can we also find delta U in the process? Is it 0? Tell me, Ved, is it 0?
No, sir.
That's good. Why it is not 0 and what it could be?
It's a real gas, so it depends on volume also.
Yes. So do you know how to solve this question? They'll not ask in ITJ, but they can ask you giving some value. So I just want to check your preparedness. Can we get this delta V?
Yes, sir.
Delta U? Tell me the formula.
V into delta U by delta T in at constant volume into V plus delta U by delta V at constant T into V.
Very good. You want to say that del U by del T at constant V into dt plus del U by del P
Del V.
del V, sorry. Del U by del V at constant T into dV. Do you say this?
Yes, sir.
Very good. So tell me the first term is equal to what?
0.
CET. But it is not going to contribute because dt is equals to what? 0. So this is equals to 0. So second term is going to contribute del U by del V at constant T into dV. All right. Okay. So how to get the del U by del V? I should not be asking, but if I ask you,
It has a relation with respect to pressure and temperature, du by dv. I don't exactly remember that.
Okay, you don't remember it. Suppose I give you this value. That's a very famous number. In thermodynamics, this is a very important number. In fact, this concept, and that is equal to T times of del P by del T at constant V minus P. Suppose I have done some mistake. Can you tell me that it is all right by your basic logic? It seems to be all right by your basic logics. How to justify this? Basic thinking. कैसे पता चलेगा मैंने कोई गलती कर दिया? आपको कैसे पता चलेगा कि ये सही है? It making sense because I'm not going to derive it. We can derive it, but what to use of derivation?
By dimensional analysis.
Yes, great. I always want to listen the simple thing, dimensional analysis. Tell me how you dimensionally pick it up.
First, U is energy term, so energy by volume is
Very good. U is energy term. U is energy term. Energy is basically P into V term. You always do it. Divided by U. Divided by U, it has a dimension of pressure. And you can clearly see there is a dimension of pressure. Okay. So in this way, it's a very important relation in thermodynamics. We call it thermodynamic equation of state. Why it is so important? Because you see this here, it is an absurd quality. This quantity you never know. Absolute value of this could not be known. But thermodynamics is telling you the rate of change of this particular thing, which is so obscure, you could not get that value with volume at constant temperature is related to such silly things. Change of pressure with temperature at constant volume of the system minus pressure on the system. So these silly things which you can always get in the laboratory easily can tell you about the rate of change of U. That's fantastic. So that is why in thermodynamics, we call this equation as a master equation. Fantastic equation. In fact, such a big equation this is that you can say the whole first law is based on this. Whole first law is based on this. That's why I asked you this question. Now, can you do it? So we already have this equation, which is looking very peculiar equation, which is P is equals to what? RT by V and plus BRT by BRT minus A by V square. Okay, and if you put here N square and you put here N, it's all right. So can you find del P by del T at constant V? Of course you can get very easily. So that is going to be equal to what? NR by V plus N square BR by V square. That is del P by del P. If you just multiply it by T, so T times of del P by del T at constant V minus P, if you just put it like this, then it will become once again nRT by V plus N square BRT by V square and minus nRT by V. I think there was a negative sign, positive sign. Positive, all right. Minus N square V RT minus A by V square. So we can see that this term is also going to cancel. This term is also going to cancel. So we are left with what? This quantity, which is del U by del V at constant T becomes what? Minus N square BRT minus A by V square.
even BRT is cancelled.
Oh, sorry. And then this minus and minus will become plus then. So this is N square A by V square. Fantastic. That is del U by del V at constant T. So we can say that du becomes what? First term was 0 plus n square A by V square into dV. And now you integrate it and you can get the value of delta U. So you got delta U, you got W. So what you can got? You also got what? Q. And if you get Q, W, delta U, then you will also get delta H. How to get delta H in this process? So delta H in this process will be calculated by this formula. Delta H is equals to delta U plus P2 V2 minus P1 V1. You'll not be using the another formula, that delta H by delta V, not like this. It will become very complicated. So here we will get this. So this question can be one of the questions. They'll set it a very nice value. They will put a very nice value and they'll ask sometimes, because they're also tired of asking the same question many times. So they can ask you, and it is not a beyond question. And regarding this, they'll give you this value. They'll provide you this. That's such a fantastic equation this is. Okay. So see, this question can be done and easily done. But the master stroke is the dimension. That is the great thing. And you help me out. I will say that you help me out because I was doing a mistake. So that is great. Good. चलिए भाई, क्वेश्चन तो सॉल्व किया आप लोगों ने, मुझे हेल्प भी कर दिया. क्वेश्चन नंबर 8. 1 mole of a van der Waals gas at 300 Kelvin expand isothermally and reversibly from. Can it be done? See, I already given del U by del U. The dimensions are there. So 7 and 8 are related questions. And see, we can give twist to this. Already you can see delta H, delta U, everything can be calculated. Already told you, first you will calculate delta U, then you will calculate what? Delta U already know. You can also calculate W. And once you get W, you can also get delta H is equals to delta U plus P2 V2 minus P1 V1. But there is one problem. We don't know pressure P1 and we don't know what. So I think delta H calculation will be very difficult. Because we know the V1 and V2. But we don't know where P1 and P2. How to get it?
Van der Waals equation.
Yeah, so that calculation will become very lengthy. But it can be done. Okay, so avoid calculating this delta H if we really want to calculate it now. So the examiner will also provide P1. At least if P1 is provided, one calculation is you can do. But if they are not giving P1 and P2, that means a big question, because you have to calculate P1, you have to calculate P2, then only you can get this. So these are the questions which tells you during isothermal process, delta H is not equal to 0, delta U is also not equal to 0. Have you solved such questions? See, today's class I have taken a lot of questions on condensed state. And you might have noticed that ITJ is asked about diamond and graphite and all this in the recent examinations. So what is happening? Their question is, getting thermodynamics, usual question they're asking, ideal gas processes they're asking. They have asked so many questions. In physics, they keep on asking only those questions. Ideal gas, ideal gas, ideal gas. So they were never talked about the fluid. And it is such an important thing in thermodynamics. So in my guess, any time you can get a question on alpha and K, giving the value of alpha and K. That is why I have taken an inspired guess that what is coming into the ITJ's mind now in advanced examination, just to differentiate between toppers with the rest of others. So this question, what is happening? Temperature of water is raised. Temperature of water is raised from 25 degrees centigrade to 50 degrees centigrade. So what is the problem? Delta T is equals to 25. Good. Under a constant pressure. Okay. Given CP is also given. So What is the problem? Calculate W. So this is a special problem where you always write delta U is equals to NCV delta T. In this question, what you are going to do? Basically, since Cp is given, Cp into dt is going to be delta H. Can you use this?
Yes, sir.
Since the process is isobaric, you can say Cp into dt is delta H. No, this is only, yeah, this is true. Why? Because we know dH is equals to del H by del T at constant P into dt plus del H by del P at constant T into dP. Right now, if dP is constant, then this is going to vanish. So dH is equals to Cp dt. So I think this delta H can be easily calculated. N Cp dt integral. What about delta U? How to calculate this?
Delta H minus P1 dV, P2.
But you don't know P1 V1 P2 V2.
Pressure is given from alpha, will get delta V from there.
Who is new guy who is speaking? My screen is. I have not that activated that thing. Those speaker will come for the view. Okay, that setting can be done by. Anyway, चलिए बताइए कौन बोल रहा है भाई? You said that we can calculate delta H. Very good. यार interactive रहेंगे तो मजा आएगा ना. Delta H तो निकाल लेंगे NCP delta T से. अब आप कह रहे हैं कि we can get P1 V1 P2 V2. How to get P1 V1 P2 V2? Suppose P1 is equals to P2 is equals to P. ये भी दिया है. What about V1 and V2? How to get this? Yes. So in this question, you can get V1 and V2. How to get this? Alpha is given. I already told you alpha is equals to 1 by V dV by dt. So if it is liquid, then we can say that V into alpha is equals to dV by dt. And in fact, we can say dV is equals to V into alpha into dt. And this V is practically constant. Okay, it is practically constant. So we can get the value of dV. So dV is equals to what? V times of alpha into dt. What is the change in temperature? 25 degrees centigrade into alpha into V will give you delta V. So you already know V1, and from this you can calculate V2. Do you agree? So you will get the value of P delta V. Of course, W is equals to here P delta V. By this approach, you will get W is equals to P delta V. Put a negative sign. So you get W. So you got W. What else? Or koi fundamentals? One more fundamental is, since the process is isobaric, QP is equals to NCP dt ka integral, that is equal to Q. So we know Q, we know W, we know Q, so we will get delta U. Delta U is equals to Q plus W. So can we say that delta U here is equals to Q is equals to NCP dt ka integral plus PdV. In fact, minus PdV integral. So we will get delta U like this, and delta H is straightforward NCP dt ka integral. So is this also a very good question to be asked? Yes. Slight twist is there, and most of the student, when they see alpha, they will falter. So don't worry about this alpha. Try to get the answer. So these are some useful questions based on the first law. That's question number 9. Try to match the answers. Now question number 10.
Sir, will final pressure remain as P atmospheres?
No, 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 no. Final pressure will not be that. No, no, no. You're mistaken. That's what you have to get.
Can we write delta U as delta N into delta T into Rs?
Avinash, please uncam. Then I can understand from your facial expressions. Yeah, just tell me the idea.
Can we write delta U as delta N into delta T into CV? Is it possible?
Just give me a question. Delta U is equals to
Delta N delta T into CV.
this. So how to get this delta N?
Delta N can be written as P1 V1 by T1 minus P2 V2 by T2.
P1 V1 by T1. Okay, this is N1. And minus P2 V2 by T2. That is N1 minus N2. You are close, but not exactly. Yeah, you are getting there. But first of all, how to get this N1? Give me that idea. I mean, N1 you can get, but how to get the N2?
He's saying adiabatic, so I will equate it with work. Speed EV I'll write, V I'll write as nRT by V1, T1.
Seems good. Good. Some kind of approach is getting. You are getting. Yeah.
Sir, isn't volume constant?
Volume is constant. That's interesting. V is equals to constant. So Avinash, this V should be like this only. So it will not come in the equation. He's
So
right.
work should be 0.
Work should be 0. Doesn't really matter. Work will not be 0 because the gas is expanding. So since you have exchanged some ideas, so I think that it's very natural that I will ask you that the thing is like this. It's a bottle like this. It must be an adiabatic vessel. Some pressure was there. Let's call this pressure is P1. Outside pressure, let's call it P2. You opened the lid, gas rushes out. So the gas rushes out. So what will happen? So some mole of gas, initial number of moles was N1. After some time, when you close it, after some time when you closed, what amount is left here is N2. Okay. And the gas has gone. Some gas has gone. At this point, you have to find out, read the question carefully. Some gas expelled to fall over. The pressure in the bottle is equal to this. Stopper is quickly replaced. The gas which cooled in the adiabatic expansion now slowly warms up until the temperature is again 21 degrees centigrade. So how it will warm up? It will not warm up on its own. You will warm it up. You will warm it up. And you will once again take it to temperature T1, initial temperature T1, because that was 21 degrees centigrade. In the process, it will then, some pressure P3 will be there. That's what they are asking. Try to understand the whole problem. Is that making sense? Avinash, now you understand?
Yes.
Initially, some moles were there. They'll definitely rush out. You have closed the lid. Now the gas is trapped. Now you're giving some heat to it. And slowly, it is getting that heat. Once again, the pressure is there. This is the situation. There are two parts to this problem. First, you have to assume that if the CV is there, what will be the CV is 3 by 2R, what will be the final pressure? And second is, if it is 5 by 2R, what is the final pressure? There are two parts to it. Both are very interesting questions. It is very close to physics, chemistry as well. And if you are practicing these questions, not only you are practicing chemistry, you're also practicing physics as well. That's the motivation for these kind of problems. Take your time because they're not going to be done in, okay? So please spend at least 1 or 2 hours. Karan, you got it?
I have a doubt.
Yeah, tell me.
So is it a reversible process or irreversible?
It is a irreversible process because the pressure difference is so large. I think you are confused by this. Now slowly warms up until its temperature is again 21 degrees centigrade. So this line is probably confusing you, but the initial is 126.4 kilopascal and 101.9 inside pressure and outside pressure is a huge difference. So the process can never be reversible.
So how can we calculate work here in the first part?
Using your hypothetical thinking. Suppose the gas is coming out, you just make an imaginary boundary around that back gas. That gas is kept on expanding. Isn't it, Ved? So I think I should not be telling you a solution. Yeah.
Can we calculate the temperature after which the gas is the stopper is removed?
Yeah. Yes. You are getting there. Yes.
If we know the temperature, can we use the formula P into 1 minus power 1 minus gamma into T power gamma equal to constant?
No reversible process. No such formula. But in fact, this is a very important method for determining Cp by Cv ratio. This method is a brilliant method, a practical way of finding gamma.
Without assuming that volume is constant, we can use first law of thermodynamics to find final volume. Suppose that there is no loss of number of moles. And then finally for a V1 volume, we can find final number of moles.
Yeah, somewhat idea is good. So should I give a first part hint to all of you? So Mikhail, try. That's a very interesting question. Once you solve this problem, that will boost your confidence. Okay. So every one of you, please try. And if you wish, then I'll also give you the solution. But I think that you can do it. You are good. Yeah. Question number 10 is very much related to question number 11. See, the method described in the problem 10 is that of some method for determining gamma heat capacity ratio. Now, in the experiment, the gas is confined initially and this pressure, ambient pressure was this, and final pressure after temperature equilibrium is this. From this, get the value of gamma. In the previous part, we have given you the CV, and this part, we are asking you to calculate the CV, giving you the final pressure. So that's going to be a very interesting thing. And I think when you get the answer, you will be, very enthusiastic. So please try to solve it. Take half an hour, but don't waste your time. Okay. If you are not getting the approach, don't waste your time because your time is very precious. Ask for a hint. As simple as that. Okay. I will share with your drive. You can write your solutions. You can share the solutions in your drive with your name clearly, properly over there. I will also put all the question bank over there. You can take the question bank, any theory part you request, okay? Cubic expansion coefficient of water is this. Enough of this, now you will solve it. Let's try this question. Pure orthohydrogen can exist in any of the 9 quantum states at absolute zero. I think most of you will start responding now. As soon as you get to some quantum states and all this, everyone start responding. Okay. So pure orthohydrogen can exist in any of the 9, or you also already know there are ortho and parahydrogen. 9 quantum states at absolute zero. Calculate kind of orthohydrogen, each of has a mole fraction of 1 by 9. Everything is revised. Simple questions are revised. All the questions are revised. So a good part of you should go for the practice. At least 5 to 6 hours do the practice. But 2 to 3 hours start doing the, reflection part, contemplation part, sharp thinking part. So there is a combination of these two. because mains examination practice part is more. Even you can do one thing, you can slightly decrease your practice part. If it is 6 hours, then you can make it 5 hours. But your contemplation part, think about it, take 3, 4, 5 good questions, okay? And don't think that they are going to be asked in ITG. That will give you a sharper thinking, in-depth thinking, and that will make you feel much better in the ITG examination. At least it will make your intuitions better. Last year, I told Shishir that, what do you think? A human being can give ITG examination and do all the questions correct? He said that, no, sir, no. So I said, what you will do? So we discussed that at least 20% questions will be inspired guesses. Any topper does that, you know. Don't tell me, sir, I know all the paper. Okay, don't tell me that rubbish. Whatever, how much practice you can do 60 to 70%. Can you think that in 2 years' time you can think and you can understand everything about the Max Planck and Albert Einstein and all the scientists? It is impossible. So core areas are there. 60% areas, your forte should be there. And for me, I say that modern physics and thermodynamics should be your forte. Why? Because it is asked in both in chemistry and physics. So put more emphasis on that. And you see, if the ITJ paper, you see that very carefully what they're asking. Mostly the problems are based on thermodynamics. Diamond to graphite, they're talking about that kind of a thing. In electrochemistry, they're relating with the what? Thermodynamics. So the part of thermodynamics, and if you understand the thermodynamics very well, you apply it in all part of chemistry. Then you understand a Lingam diagram. Then you understand reduction potentials very well. So this one part of thing is going to make at least 20 to 30% of the total marks. So this should be your forte. Okay, some other things should be forte. So 50 and 60% is your forte, that in dream you can solve the problem and you are ahead of the ITJ examiner, that what they are going to ask, I already know what you are going to ask. That's fantastic. And rest of all, if you are getting into these topics in very sharply, then your intuition will start developing. So what will happen if you see 4 options? Many a times you can figure out which option is most correct. So conceptual depth is needed for this. Sharpness is needed for this. For this purpose, we recommend that in the last moment, at least a few topics should be your forte. One of them in chemistry is thermodynamics, other is kinetics. These 2 chapters should be done with great depth and with great, precision. If you can do this, then the rest other chapters will follow. And modern physics, you are doing some wave function part, you can also do, and Heisenberg and de Broglie's. So that will boost up your confidence. Radioactivity part can also be done. So this is a very common part where you should have a upper hand, and ITJ examiner had a lot of interest in this because the whole engineering is based on the concept of thermodynamics and all this. Okay, because thermodynamics is also based on probability. You see this question 14 is based on probability, and you can write the answer like this.
Means directly from formula K times of L and number of.
Very good. S is equals to K, L and W. Tell me, what is W here?
Possible macro states.
I tell you, 9 states are possible. So that means number 1 particle has how many options? 9 options. Number 2 has also 9 options. Number 3 has also 9 options. So Na, if you have Na particles, all of them has 9 options. So that means total number of options is equals to what? Total number of options is equals to what? First is 9 times 9 times 9 times what? Na. So how many options you have? 9 times Na. My goodness, such a big number. Such a big number. That's W. That is W, weight of the configuration, we call it. Okay. These are the possibilities. That is giving rise to the randomness. Now S is equals to K, L and W, which is K into Ln into 9 raised to the power Na. So simply K into Na into Ln 9. That is your answer. That's the beauty of thermodynamics. Do you understand the solution? And I have 3 molecules. Now, how many ways I can distribute the energy? I'll write like this. These are the 3 particles. and these are the partition. This is molecule 1, this is molecule 2, molecule 3. So what are the number of ways? How many objects are there? 1, 2, 3, 4, 5. Factorial 5, factorial 2, factorial 3 is equals to W. You can also write a formula like this. W is equals to N plus M minus 1, N minus 1, M, where M is the unit of energy. N is the number of molecules. That's W. So Nikhil, think about it. If you have only 3 molecules, how many ways are there? Factorial 5 is equals to how much? 5 into 4 divided by 2. There are 10 ways. 10 ways of distributing this. That gives rise to entropy. More uncertainty is there, more is the entropy. That's called W. Number of equivalent ways in which system can be arranged. Else you can also write this by the formula. The same problem you can also do by the formula. What formula you understand? S is equals to minus nRT xi ln xi. You can also use the formula. Sorry, T is not there. This T is also in the G. So minus nR ln xi. This is the entropy of mixing. So minus 1 into R into 1 by 9 ln 1 by 9, 9 times. So that is 1 by 9 ln 1 by 9 raised to the power 9 R with a negative sign. That is equal to R ln 9. बच्चों समझ में आ रहा है क्या?
Yes.
ये फॉर्मूला तो जानते हो, ये फॉर्मूला तो पढ़ाया गया, कॉपी में लिखवाया गया. This formula you know. So we can get the answer by this formula, and we can get the answer from S ln S is equals to K ln W. So in fact I have proved that how accurate this formula is. बच्चों respond करो. Pure crystal. Pure crystal means what? All atoms in single state. You are getting into imperfect crystal. So in perfect crystal, there are 9 types of states. And this is mixture of 9 states. So going from here to here S is equals to 0. Here S is equals to K ln W. So what is delta S mix? And we already know delta S mix is equals to NR ln, sorry, XI, X1 ln X1 plus X2 ln X2 plus dash dash dash. All right, do you understand this? So this one question is based on third law of thermodynamics, which tells us that even at absolute zero, भाई W समझ में आ गया? You got W? आ गया समझ में? फिर और बताऊं, और एग्जांपल से बतलाऊं? भाई आप रिस्पॉन्ड करोगे तो बताऊंगा. मैं तो अज्यूम करके चल रहा हूं कि यू हैव डन. वेद प्रकाश, आपको आ गया W? व्हाट इज W?
Can you once repeat?
W you understand?
I mean, can you repeat W?
W is called weight of configuration. It is called, see, if a system is there at some pressure, some volume, some temperature, that is called macroscopic state. This macroscopic state consists of infinite infinite large microstates. More the number of microstate, more is entropy. Just like in a classroom, if there are 6 seats and 2 students, how many ways we can arrange them? How many ways we can arrange them? We'll have this thing, 2 students. So we have factorial 6, factorial 2, factorial 4. So in the classroom, you don't know. You say that only 2 students are there, but there are many ways in which those 2 students can be arranged. Number of ways, if the number of ways are large, then entropy is more. This idea gives you a straight touch why we call entropy as a state function. Isn't you amazed that when you studied that enthalpy, absolute value of enthalpy is not known, but absolute value of entropy is known, because entropy is related to the probability. You can accurately calculate entropy. You can have absolute value of entropy. Amazing. But you could not have absolute value of internal energy. So you're lucky that only one thermodynamic function is there whose values can be absolutely determined. And what is that? Well, that's entropy. Because of this. So this is called microstates. So in every given macro state, there are large number of microstates, and a system used to go in between those microstates. Okay. Now some of the microstates are very improbable, and some of the microstates are very probable. What do you think? Which is most improbable? Suppose there are 10 states possible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In number 1, there are only 2 ways of exchanging things. 2, 3 ways of exchanging this. 3, 5 ways of exchanging this. 4, 10 ways of exchanging this. 5, 100 ways of exchanging. 6, 10. Suppose it is symmetrical, then this is 5, this is 3, this is 2, and suppose this is 1. Something like this. What do you think system will spend most of the time in which state? This state. The whole world is just like this, statistical in nature. If you see that everything is governed by the probability, and these are the microstates. Okay, these are the called microstates. So entropy is related to this. S is equals to K ln W. This is such an important formula that this formula is written on the grave, on this what do we call stone, which has been installed on a grave of Max Planck. No, sorry, Maxwell Boltzmann Boltzmann. But fact is this, that this formula is given by the Mr. Max Planck. This formula was given by Mr. Max Planck. Anyway, come back. So that is W. Now, if you understand W, can you tell me in which case why gases expand? Okay, you ask me basic questions. Why gas expand? Why gas try to take all the space available to it? See this. Suppose this gas is there, and this is a chamber which is separating them. So before mixing, how many ways were there? Factorial 6 divided by factorial 4 factorial 2. If you remove this, what will happen? Then it will become factorial 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Factorial 12 divided by factorial 4 factorial 8. So what happened? Why system goes from state 1 to state 2? That was state 1 and it has gone to state 2. Why?
Number of exchanges are more in this.
Yeah, because W2 is increasing. We are going into the most probable state, and in the most probable state, entropy is more. Uncertainty is more. So gas always, everyone wants to go to which state? Which is more improbable, which is more what? Which is more uncertain. And that is the concept of entropy. Everyone wants to go there. Is that clear? Now you understand what is W?
Yes, sir.
So we have solved this question two ways. One was macroscopic way. In macroscopic way, we find delta S mix is using the formula minus NR x1 ln x1 plus x2 ln x2 plus dash dash dash. Another way we have find out delta S simply by K ln W. Both has given you the same result. And in fact, we can use this tool to tell you how accurate this probabilistic definition of entropy is. That is the proof of this. Okay. So this one question is just to understand you, for one single line of the NCERT, entropy of every perfectly crystalline substance is 0 at 0 Kelvin. But for imperfect crystals, it is not equal to 0. Okay. Even in ice, the water has the tendency to change its configuration. It can rotate. So if it can exchange its position, these two hydrogen can exchange its position at 0 Kelvin. So that corresponds to what? Two configurations. So even in ice, there is some residual entropy. So even the crystal of ice is not perfect even at 0 Kelvin. If you take ammonia is in solid state. What do you think? Is it a perfect crystal? Ammonia is going to make a perfect crystal? No. These hydrogens can what? Exchange its position. So there are equivalent, how many configurations are there? For every, there are 3 configurations. So even the perfect, at perfect is 0, at absolute 0, even ammonia will have some residual entropy. So they have residual entropy, okay? So that is why absolute 0 पर इनका entropy 0 नहीं होता. So your graph will look like this. Something like this. S versus T graph will look like this. This value corresponds to residual entropy. And for perfect crystal, it will look like this. Okay. So this is where we go ahead. All right. So should I discuss this at least isoelectric point? One question, should I give you the whole solution? Or you will try? Tell me. In the next class, I can discuss.
We tried.
You will try. Oh, that's great. That's great. You try. Please don't waste a lot of time. And please don't get depressed. Even if you don't do it, no problem is no, they're not going to ask in ITJ. Only thing is your just brain teasers are there, which will make you concentrate even harder. That is it. Because if you have done a lot of questions, there are no motivation for this. So just make your concentration. You have to concentrate hard. That is the aim. So have fun. If you don't have fun, please don't do it. Okay. And if you want some basic classes, then you can ask specifically, sir, I want basic classes. In the previous class, you told something about dilution. So I have some basic things. But if you don't speak, then I don't understand your expectation. Okay. What do you want? There are, for us, there are 100 ways of teaching. So what way I should take? Not 100 ways, at least 10 ways of teaching are there. Depending on what students require. So you'll have to come up and tell me. Yes, Karan, you want to say something?
Oh, can we do some more things on ionic equilibrium?
Ionic equilibrium, yes, of course, why not? I will share you a very nice sheet where these questions are full of these questions are there. That will make your confidence level very high. I can do it. And I love to do it because that is students really enjoy that.
Sir?
Yeah.
So can you give us some models in Faraday's law, sir?
Faraday's electrochemistry.
Yes, sir.
Farad law is very easy, beta. What do you want? Farad only part in Farad law is which is slightly difficult for the student is over voltage. But I can give you. Nevertheless, what is the problem? Farad law is what? One equivalent of electricity when passes, one equivalent of a substance is deposited at cathode, and one equivalent of substance is deposited at anode. That is it. So what part you find difficulty? Uncam, tell me. Where is the difficulty in Faraday's law? I try to understand. What part you don't understand? Please, Uncam, tell me. Face to face. See this ionic equilibrium. I think who asked for ionic equilibrium? Karan. See, I always start ionic equilibrium with a simultaneous equilibrium. Because if you do simultaneous equilibrium, ionic equilibrium is very easy. So you see these standard questions are there. They're very nice questions, standard questions of simultaneous equilibrium. There you have to apply, take some approximation to solve the problem. If you solve these questions, you'll get the total feel of ionic equilibrium. Ionic equilibrium is nothing. If you are not good at taking approximation, you will face problem. But if you're good at it, you are into it. It's the easiest chapter. Every time I'm making whatever problem, 2-line solution is there. But if you don't get it, solution can go 5 pages. Okay, so that is the idea. So you can focus on this. I can give you this. See, all these questions are there. Strong acid calculations are there. I'm still making it in all these questions. The calculation part is very simple. Calculation part is very simple. How much water should be added in 100 liter of HCl solution having pH 3 so that the pH of the resulting solution is 6.9. Given log 10, 1.2589 is equals to 0.2. Something of this kind. Okay, you do it, and problems which I create is something which don't require calculation, only concept. Similarly, I give this kind of, just fill in the blanks. In all these cases, just fill in the blank. Suppose these are the acids and these are their Ks. So this A, B, C, D, E, F, G part will it requires your 15 minutes time. Do it and you are perfect, and find the alpha. They are very interesting question. They require some thoughts. Small amount of thoughts like this. So just fill in the blanks and it's all there. Very easy. Mixed acid calculation. I'm still developing it. A lot of questions are there because I have a habit of just doing the questions and just forgot my questions. So many years I have done because it requires only classroom and few things. You can create the question at your will. So, but this time I started, since I'm on the online, started taking all my questions back and compiling it. So you do it, no problem. So I'll share this sheet, do it. It makes sense that you should have a lot of confidence in ionic equilibrium. Do you have? An ionic equilibrium, believe me, requires no formula. If you are doing it by formula, you are mistaken. Zero formula. कोई फॉर्मूला नहीं है. हाँ, 1-2 फॉर्मूला है, ठीक है, और वो 1-2 फॉर्मूला वही है. H plus is equals to under root of K1 K2. And what is the approach of solving that formula? Would you must know. तो थोड़ा टाइम डिवोट करो. आपके पास अभी टाइम है. This chapter should be your forte. So if you are into it, I can take the. अगर आपको लगता है ऐसा मैकेनिक में आपको क्लासेस चाहिए तो आप उसकी बेसिक्स पूछो. पहला आप ये शीट करके आओ. ये I'll share it. Okay, simultaneous equilibrium. So just try few questions in this. They were all very interesting. Calculations are very simple. ठीक है, कोई भी
Yes,
ट्राई
sir.
वैसे कोई भी ट्राई कर लोगे अपने आप मजा आ जाएगा तुम्हें. पहला क्वेश्चन एकदम ओरल है तो slowly build your ideas. So ionic equilibrium is very simple chapter. Do you know the charge balance? Charge balance approach, ठीक है बच्चों. तो आप अपनी जो डिमांड्स हैं अगर इन चैप्टर्स की पढ़नी है, देखिए हमारे पास बहुत से अप्रोचेस होते हैं. आप ऐसे करना चाहते हो ऐसे कर लेते हैं, और इसके क्वेश्चन बैंक, ऑर्डिनरी क्वेश्चन बैंक देना चाहते हो, ऑर्डिनरी यूजुअल कर सकते हो. बट आई बिलीव दैट ऑर्डिनरी अगर आपने कर रखा है, देन वी कैन गो फॉर समथिंग स्पेशल क्वेश्चंस व्हिच आर फ्यूचरिस्टिक क्वेश्चंस. They can be asked in ITJ. अभी आने वाले टाइम पे पूछे जाएंगे क्वेश्चंस, वैसे क्वेश्चंस मैं आपको करा रहा हूँ। ठीक है, पिछले बार भी मैंने बोला था कि क्वेश्चन आएगा, एग्जैक्टली दैट क्वेश्चन हैज केम. So somebody asked me in the interaction, I tell you. ठीक है बच्चों, आप लोग का भी टाइम है, पढ़ाई कर रहे हैं आप लोग, ठीक है. So anything you require, you try all these questions, come back to me in the next class, I'll discuss the solutions. And meanwhile, if you can get the solution, you can get my number, or you can else write your solutions, give your solutions to the Prasad ji. I will share the answer key with him. Answer key will be provided to you, answer key, not the solution, tomorrow. One day time I am giving you to try the problem. That will give you some thrill of the problem. Is that okay? Ved? Tomorrow I will share the answer. Done? Okay, bachcho. Take care. Bye bye. Let's meet in the next session and solve all these questions.